My name's Todd Bell. I'm with the Frontier Energy and the Food Service Technology Center. Has anybody been out to the Food Service Tech Center in San Ramon? One? Two? Handful? Awesome. How many of you cook at home? Right. How many of you have a gas range? How about an electric range? How about an electric induction range? Got one? All right, cool. How many of you have heard of induction cooking? Awesome. Yeah. Well, so I'm going to do a little more deep dive into what it is and the magic that is induction, and why we're looking at it as as we go to the all-electric future, why it's going to be a key component on for residential as well as commercial. So those of you not familiar with the Food Service Technology Center, we're a 35-year energy center out in San Ramon that focuses on energy efficiency in the commercial food service world. But in the past few years, we've started to dabble in the residential world, doing testing on commercial range tops, which includes induction hot tops as well as gas. So we are in a key position to be able to analyze the differences between the two from the technical performance side of energy efficiency, and well as all the other attributes that are the sell points for those different technologies. So I'm going to be talking about going into induction, how it works, and then finishing up with like all these considerations about the barriers, pros, cons, and things like that. So what is electromagnetic induction? It's been around for a long time. It was discovered back in 1831 by Michael Faraday. And essentially, it is the production of an electromagnetic or motive force across an electrical inductor in a changing magnetic field. It's a mouthful. But we experience it on a daily basis. You know, it's all over the place. It's in many applications, from electrical components, motors, generators, and cookware. So how does it work? What is this all about? So basically, you are creating an electromagnetic field with a copper coil underneath the cooktop surface. And when you place that magnetic cookware, whether it's a pot or pan, in that field, it creates an oscillating current. Then you have a resistive heating occurs, and it starts to heat the pan. So essentially, the appliance itself, the induction hot top, whether it's a portable unit or a built-in range at your house, they're acting as a system. You do not have heat unless you have the pan, right? Which is pretty cool. So essentially, all that energy is going into the pan, makes it highly energy efficient. And when you take away the pan, you're not consuming any energy. So it's really cool. I was just recently at the Energy Fair last week. Great event, fantastic turnout. People were like, they saw the demos. There's another vendor there with a really cool induction cooktop technology. They had like a killer app and a pan that talked to the app and the cooktop thing. I was like, oh my gosh. And then I kind of had the thing ripped apart at my table and showing the guts and how it worked and going through this stuff. And people were really like, that is super cool. What they really were impressed by is that you could take the pan off and then immediately wipe it down with a rag, or if like there's no water on it, or you could pretty much put your hand on it, because it's not like a resistive heat coil that, as I learned as a child, even though mom's walked away and the pan's gone, you can still burn yourself, because that thing, even if it's turned off, doesn't cool down very quickly. So at 4 years old, I learned pretty quickly, don't touch those things. So danger, danger, danger. So stranger danger, stranger electric hot top, right? So much different principle. It's a resistive heating element that's heating up, and then it's the contact between the cookware and that heat coil. You have conductive heating, okay? So not as efficient. That coil has to heat up first, and then through conduction, it's heating the pan or pot or your child's hand, whatever's up there. So that's how that works. Pretty rudimentary, been around forever. They're slow to heat up. You're not as efficient as induction, but it is the most common application we have out there for electric range tops, and relatively inexpensive, right? You could also have, and people will sometimes mistake induction hot tops for ceramic hot tops, glass tops, and basically that's just a resistive heat coil beneath some glass, and it's relying not only on conductive, that contact with the surface, but also radiation. And these can be even slower to heat up, but it's more of an aesthetic element, right? And they're easier to clean too. So that's why they're out there, but not very, in comparison to induction, not very efficient, but relatively common. Cost is, you know, they're not that expensive, but they're all over the place. Some of you might have, how many of you guys have one of these at home? Yeah, they're kind of all over the place. Public enemy number one these days, natural gas, right? I have gas at home. I admit it, but, you know, my wife, now that I'm thinking, hey, we should get one of these induction hot top, you know, ranges, she's like, I like the look of the gas, but I do all the cooking and I have to do all the cleaning, so I'm trying to, you know, fight that battle. We're getting an electric car soon, so I'm going to win there. But this has been a tough one. But it's understandable. Gas, there's a certain aesthetic to it. People like the look in their homes. You know, folks are putting commercial grade Viking and Wolf ranges in there. Just, I've seen all sorts of insane stuff. And you know, you go on house.com, it's like, oh my God. Then they got this rinky-dink little exhaust hood over it. Like, what? You got a restaurant in here? No, it's crazy. It's talking like 200,000 BTUs of power. It's ridiculous. But anyway, so it's relying again on, you know, radiation, convection, but not very efficient at all. Most of your heat, and just, yeah, we're all familiar with that. So it is being lost around the side of the pan. It's not doing a very good job of transferring that heat energy into the pan and ultimately into whatever you're cooking. So part of what we do out at the Food Service Technology Center, on the efficiency side, I forgot about this one. Yeah, this is the other consideration, right, is this. Is that you got the gas byproduct, a lot of NOx, residential range hoods, and we've done testing and evaluation on these guys. They're horrible. I've got a pretty good one because when I remodeled my kitchen, I knew that this was a kind of a big issue. So I made sure to really research it, find a system. I use a Ventahood. It's got like 400 CFM of exhaust. But if you look at some of the heights, like this, that second from the left, it's like probably 100,000 BTUs worth of gas, and look at the height of that hood. So on the far right, that picture there is we have a heat imaging camera in one of our test labs at the center, where we can look at the exhaust plume coming off of equipment, and you'll see that, and that's essentially all that cooking effluent and heat is spilling from the hood, and that's a commercial grade hood that's been specifically designed to exhaust these appliances. On the residential side, your Newtone hood or whatever $10,000 exhaust hood that one is in the middle, or that little island canopy one in the third slide from the left is, it's not doing anything. It's just looking pretty. It's like, oh, you walk in, you got all this bling. The other problem, and I recognize it with my system, is I've got great exhaust and good capture if I have enough makeup air coming into my kitchen space. So in the wintertime, what happens? I've got all the windows closed up, hood's running, but you start to get spillage, right? You got to crack a window open to allow enough makeup air to come in and replace that exhaust air, because you're sucking on a vacuum at that point. So anyway, that's another, again, gas ranges, they're introducing all this nasty stuff into the kitchen space. Another drawback. Now, when I'm talking about efficiency, what does that mean? We actually have a standardized test method where we can figure out how much energy goes into the cooking appliance. In this case, the electric burner or gas burner, or whatever it might be, actually makes it into the food, in this case, the water that's in the pot that's being boiled. And so it's a direct measure of useful work. And on all of our tests, especially on the cooking appliance side for commercial industry, we use real food products. So French fries and fryers, apple pies and rack ovens. Yes, it's awesome. Fries never get old. I'm amazed I don't weigh 100 pounds more than I do after 30 years of working at the lab. But anyway, so we have a water boil test, and what does it tell us? There is a huge disparity in energy efficiency between induction, standard electric, and then gas. And that's that big one, right? So induction is 86, and we've seen some units up in the 90% efficiency. So most of the energy it's consuming is going directly into the food that's being cooked, right? Because again, the pan is taking on all the energy. As soon as I put in that electromagnetic field, it becomes the heat source. Whereas gas, 70% of the energy consumed is completely wasted. It's going out the sides, it's just going up into space, heat into the kitchen, up the hood. And that is for any gas appliance. I can say from a standard efficiency gas fryer, griddle, oven, 30% is what you can expect. There are some appliances out there like gas steamers with boilers that are down at 5% energy efficiency. So if you went into probably 85% of the kitchens right now that are getting ready for lunch service in the city, only about, maybe best case, 25 to 30% of the gas energy that they're consuming is actually making it into the food products being cooked. So when we're talking about how are we going to meet the climate change challenges and meet those goals, we got a lot of work to do because industry standard is cheap, low-cost cooking appliances that are very inefficient. Fortunately, based on the research we've done over the past 35, 40 years, we've got Energy Star for these cooking appliances. So in some categories, like fryers and griddles, yes, there are options. There's more efficient equipment. But even your best Energy Star griddle is only about 49 to 50% efficient, right? You just cannot transfer all that energy efficiently into what you're cooking. So on these residential ranges, this is what we found. Performance difference. The induction is significantly faster, twice as fast for our boil test. I have a little portable hot top that we use for our demos. Brought it home. I've been cooking on it for the last couple of weeks, and it's awesome because they say put the pan on, 2 seconds later it's hot, put the cooking oil in there, and I'm scrambling eggs, and I'm done in 3.5 minutes. Whereas my gas, when I was doing with the gas, it takes twice as long. So it's been really, really cool. I have to kind of change up my process. I have to fire my toast earlier before I start, to make everything match, right? So it's a fantastic technology. So cost, of course, is going to be an issue, right? And that's one of these hurdles we really have to address. Fortunately, induction has come down, but your basic resistive heating element ranges, you walk into Sears, you walk into Home Depot, you can walk out with one for about $300 to $400. Okay, very basic. Your electric ceramic, you want to get something a little more fancy, price point goes up. You're going to maybe introduce some other features in terms of controls, things like that. You might be at $600 or premium up at $3,000. Induction, though, prices come down significantly. If we went back 10 years, your base model, gosh, it would probably be about $4,000. And just so you know, Westinghouse introduced induction cooking back in the 60s with a unit at I think it was a World's Fair or some technology expo. So it's been around a long time, but back then it was just so hellaciously expensive, it never took on. It took off. So hence it was either the resistive heating element types or on the gas side. And as you can see, that price point, a basic $400, $6,000. I've seen some even up in the $8,000, but those are like the really fancy, like I said, almost commercial grade type gas ranges that our folks are putting in their 10,000 square foot mansions. So, but again, pretty big price range. What does it mean in terms of operating cost savings for the typical homeowner? It's kind of a wash. So, your electric, you're going to save a little bit. And this is really based on the general population, how much cooking we tend to do. It's not a ton. I cook quite a bit, and my base load for my water heating and my gas use in my home in the summertime, and a gas dryer. I'm all gas. Hey, I got some work to do, guys. I'm not going to sit up here and say I'm the electric angel, but it's about 6 to 10 therms a month in the summer. So I'm not using a lot of gas, and I do use my oven and my gas top range a lot. So, but induction, it's going to be about equal, and gas is about $30 a year. Electric prices are such that gas is always or tends to be less expensive. Where we get the gains with induction, of course, is the performance and that it is so efficient that it can get relatively close to gas. And we're finding on the commercial side, which I'm going to dive into in a sec, is that your usage goes up and that delta and the performance of the commercial grade induction units are so much better than the residential ones that it's becoming almost a wash in terms of cost. Loaner programs, we've been supporting City of San Jose, Palo Alto, Sonoma Clean Power, San Francisco, I think was going to have one rolling here potentially, hopefully soon. PG&E's looking into it. So City of San Jose, Palo Alto, I've been loading out this little countertop unit, $65. I've been playing around with this at home. It's awesome. It's really cool. It's programmable, has a timer feature in it, really good controls. You've got fantastic temperature response. So as a loaner program, or if somebody just really wanted to check out induction, hey, is it for me? Is it something I might be comfortable with? This is really, really, really cool. I've actually seen some on Amazon down around $30 to $39.95. Don't know the quality of those, but at that price point, it really does make it possible to check out the technology. On the commercial side, of course, this is here in the city restaurant. You got the induction hot tops there on the left by the oven. All sorts of applications, right? So we've not only hot tops, but griddles, lots of holding equipment. Next time you go to a hotel, maybe you haven't gone through the buffet line. There's a good, or you ask for the guy to make you an omelet with all the fixins. Good chance he might be working on an induction countertop unit. We have induction woks and all sorts of warming equipment that's come onto the marketplace in the last 5 to 6 years. And of course, the cost has been coming down dramatically. So we're really excited about these other applications for induction heating in the commercial food service sector. Shanghai show, they had a full suite there with an induction wok. And that's going to be a big challenge, because with induction cooking, getting this very conservative industry to separate themselves from gas and just having fire flame that's just there on demand, it's going to be a challenge. But it exists. These are really high power induction woks, hot tops there, and a stock pot burner too. So this was from last year at the show. Some of our colleagues were there, and so exciting stuff. Other advantage of the induction too is it's less radiant heat load in the space, which is cool. So a lot more comfortable to work in front of, which goes well in line with new Cal OSHA requirements for interior spaces and heat load. So those are things that this type of technology is going to be important to get at. But there's an example of the electric, gas, or standard electric and gas and induction. So real world applications, when people put in induction, they're happy. It's fast, easy to clean. This is Matt Greco, owner of a restaurant down in Pleasanton. He loves his induction cooktop. Takes him like 2 minutes to just wipe it down, and he's done. Doesn't have to tear down the range. Big labor saver. So I'm just going to leave it with some of the pros and cons associated with the induction. Answer all your questions, so you don't have to ask me any questions. I'm off the hook. Let's leave that up there for a second. You kind of get an idea of our thinking and how we're going to sell this technology to the industry, homeowners, as well as on the commercial side.
Thanks so much, Todd and Keith. 2 more great presentations to the forum this morning. I'm going to ask the other panelists to make their way up, but maybe if anyone has some immediate follow-up questions for Keith or Todd, you can ask those now while the rest of the panel comes up. Microphones are roaming around the room.
Todd, I have a question over here. Just about other adapters for, like my wife has tons of cooking pots and so forth, so there's not just the cost of the stove. Right. They're not going to work on that. So,
right. So
how do you answer that question if it's not on your list?
If it's a magnetic pan, so get yourself a kitchen magnet, and if it works, stick to the bottom of the pan, you're good to go. Typically, all aluminum pans or pots aren't going to work. They will work, but very, very poorly. So the key is...
I was wondering, how much can you reduce the size of the exhaust vent if you switch to induction?
Yeah, so you would be able to reduce your exhaust ventilation rates definitely on the commercial side, just because the heat load is going down so significantly. So you would get additional savings there. And I've noticed just at home, because as soon as I turn on my range, I've got to turn on the exhaust hood to deal with the gas byproduct. Where with the induction, I could turn it on after I just part steam or whatever. And that's why when you go to a buffet line, you'll see them using induction, because they don't have to have an exhaust hood. That's a great question.
I have a question from the webinar. Do you take into consideration the cost of purchasing new cookware with the cost of induction? Sort of following up.
No, that was just with the appliance itself. Yeah, because the cookware is kind of all over. Oh, and if you are out buying, besides walking around with a magnet in your pocket to test all the pots and pans you see at the store, you can also look on the bottom of the pan and you'll see like a spring kind of symbol, like vertical or horizontal, and that will say it's induction ready.
Also, you require a 240-volt circuit for that as well, right?
Yeah, so the larger full ranges will be 240. Those countertop units are 115 volts. Oh, okay. Yeah, and one that I was using at home, that was running at about, I think, 11 amps at maxing out at 1300 watts. So yeah, just plug it. Haven't popped a circuit yet.
I have a question for Keith. You mentioned that the internet is more favorable to heat pumps now than what it used to be. What about just natural demand? Are you getting more homeowners asking for them? Because I know you're pushing that since that's all that you install.
Hello? Yeah, lots more demand now too. So most of the people that call us don't call for heat pumps, but that's what we recommend, and then they usually trust us by that point, or something happens. They like the idea a lot more, but we do also now get calls where people say they want heat pumps, which usually didn't happen before.
And Jennifer West at Stop Waste, to follow up on that, when you recommend it and a homeowner says, no, thanks, what's the reason?
The reason they don't want a heat pump, or they don't want to work with us? Sometimes it's electrical cost and the unknown factor with that. Usually, or possibly they had fear of it not working well enough, but usually it's just because of electrical cost if they have what's called a ridiculous home that uses just tons and tons of electricity. Things like that, yeah. Or cost, I don't think is usually the issue, because our same product that we would be doing, which would be maybe a hydronic air handler, would be very similar.
Keith, what about tankless in relationship to efficiency versus heat pumps?
It depends how you look at efficiency, right? So the highest efficient tankless water here is maybe 96, 98% efficient, and the heat pump is 300 plus percent efficiency. The heat pumps aren't making heat. They're transferring it from the air to the water. So if we compare it that way, the heat pump's more efficient. Tankless are fine. People normally like tankless because the hot water never stops, and they can put it in really small places, where the heat pump water heater has hot water instantly because it's holding it. And then people may have to stop. So in the long run, the heat pump water heater will be more efficient. So I guess it's hard to, I don't really understand the question. I don't think, like, efficiency that way. As far as cost, like operational cost, well, depending on your utility rate, the heat pump water heater could be more, and depending on your usage, the tankless could be more. So if it's never ending hot water and you have 3 teenagers at home, I'd assume that the tankless may cost you more.
I have a question from the webinar for Keith as well. Is there a reason you did not isolate out energy consumption for the clothes washer and dryer? Do you have an idea of actual percentage?
Oh, on my graph? I did, yeah. Well, I monitored all the circuits on all the homes, so I have it. It was just very low. So especially the washer, like nothing.
I have one kind of for the whole panel, if that's okay. First of all, thank you, all of you. So I work for Contra Costa County, and this has been very timely because our Board of Supervisors is interested in the idea of considering an ordinance similar to what some of the other local jurisdictions have done to encourage going all electric, either a gas ban or something that would provide incentives of one kind or another for people to go all electric. So I've learned a lot today. I've learned that it seems like going all electric pencils out economically in many cases, and of course it has tremendous energy saving and sustainability advantages. So it seems like a total no-brainer. This is the way the world is going to go. Problem is, a lot of the public doesn't understand this yet. So you're going to have a lot of homeowners and a lot of business owners who think that you're forcing something that's unreasonable down their throats because they don't understand that this actually makes sense both economically and environmentally. So my questions are, what are your thoughts on how to counteract the lack of education and information that it seems like it's still pretty pervasive? And that's going to, of course, affect the politicians because they're not going to want to make all of their constituents unhappy by doing something that their constituents perceive to be heavy-handed government intervention. So how do we deal with that? And then how fast can we get this into the statewide code? Because I know our board would be a lot more comfortable doing something if they felt like it was going to become statewide regulation very soon. Thank you.
I think one of the most powerful arguments that I've seen is that PG&E is actually supporting every local reach code for electrification policy right now. And they've actually stood up and said, you know, we don't want these halfway electrification or the exemptions for cooking or fireplaces and things like that, because they still have to put the gas infrastructure in. And they know that we're going to have to decommission the natural gas supply system over that investment lifetime. So for new construction right now, if we're paying 50%, you know, the developer's paying 50% of the investment on that gas supply system, and the ratepayers are paying that other 50%, those are going to be our least economically capable folks to get off of the natural gas system. It's both an equity issue and it's a long-term ratepayer, because that's going to be the most expensive infrastructure. It's not the commodity that we need to put in that pipe. It's the maintenance of that pipe over the lifetime. I mean, those are the biggest arguments that I've been able to push. If PG&E wants to get out of the gas business, let's help.
So your question's fantastic. So on the residential side, I think it's going all electric. From our perspective, on the cooking appliances, totally doable. On the commercial side, it's a completely different ballgame, because I just showed you one appliance where it makes sense. Do keep in mind that a typical restaurant is 5 to 7 times more energy intensive per square foot than any other commercial retail operation. So you can think of a Staples, office supply store versus an In-N-Out burger. Your In-N-Out burger's energy cost is actually greater than the Staples. You think about all the energy systems, all the equipment that's in there. So there are certain appliances like fryers, griddles. If you go electric, your operating cost is going to go 4 to 5 times more, just because electricity is so expensive in PG&E service territory. Other places in the world, Pacific Northwest, go to Minnesota, where you're 6 to 7 cents a kilowatt hour. That's where the electric appliances make sense. So we've got to figure out, one, selling people on these electric equipment, whether it's the induction where it totally makes sense, and either weaning them off certain cooking processes that are expensive, where if they put an electric fryer in versus the gas, they just increase their operating costs by 4 times, right? Hitting the bottom line. Typical small restaurant that we work with, your average monthly bills are $2,000 to $3,000 a month. Very expensive industry. I mean, that's why we have, they're under such tremendous pressure now. Labor, rent, just food costs. So when they get the utility bill, it chops the profits down, and that's why we have such churn in the industry. And what's the average lifespan of a restaurant? Less than a year, out of the gate. So while we're big proponents of electrification, there's all sorts of benefits. It's going to be that operating cost challenge that we've really got to deal with, just because of the expense of electricity, and then that infrastructure cost too, and the service requirements in these buildings.
So as far as banning gas for the whole state, that's a very sensitive issue. If you have, issue at the local level, imagine at the state level times a billion. So we gotta do everything we can to enable fuel switching, decarbonization, but so harder to ban from the state level at this point.
But I guess having very clear compliance options for as many building types as we hope to see get built all electric, and having that stated in the code very clearly, so that local jurisdictions can adopt those codes, is maybe what Jason's kind of thinking
absolutely.
about.
So we talk about standards, mostly about compliance options. There's going to be more compliance options for the electric side. Something I didn't talk about is about the 2022 standards. We are working on that right now. And, as part of that update of the TDV, we're looking at adding methane leakage as part of the calculation, as far as refrigerant leach, GHG impact of the refrigerant. So that's starting to tilt towards electricity. So.
Oh, sorry, this is close to me. I wanted to kind of piggyback on his question, and I'm curious. When we're thinking about gas and maybe not bans, but just incentives to get people to build all electric in the new buildings. We know that generally speaking, the cost is lower for those, for the building construction costs, but still there are people who are choosing to build gas for the operating costs or cultural reasons. So I'm just curious if any of you has an idea of, if you're thinking about the industry at large, what the kind of cost differential would need to be to incentivize a large number of people to build electric. Is just the kind of equal playing field or slightly cheaper electric enough, do you think? Or do you think, maybe a 10% cheaper electric building would be enough to really make a big change in the industry? I'm wondering if any of you has an idea of what the cost difference would need to be.
We've been doing a lot of work with the kind of the cost effectiveness reports for all these local reach codes, and there's one thing that's I don't want to. It's an interesting incentive in that cost equation right now, because if you're only paying half the cost of the gas infrastructure to your residents, right, for instance, and the rest is on the ratepayers. If that cost was 100% to the developer, it would be way cheaper almost always to build all electric, right? We're subsidizing that gas infrastructure right now. The ratepayers are. And in those instances, so some of those subsidies, I would say, need to go away, or at least changed. And with every project, and Brad can probably back me up, the commercial projects we have, if we start the design from all electric, it's almost always cheaper than a gas option. Almost always. I've only had one project that had a cost premium for it, and it was because we changed it at 90% heating. It's a huge change to the project.
I'd like to say something too. When we built those homes with no gas infrastructure, the electrical infrastructure and the gas infrastructure, you have to work with PG&E. I suppose I should ask if anyone from PG&E is here, but it's a total nightmare dealing with them. Not only the cost, but the calls and the scheduling and all these conflicts. And so to not have to deal with half of that issue, because it's not the same people you deal with, it's a totally different side, and they're just horrible. So as a small developer, like my brother and I were, it's much easier just to do electric, even without the cost.
I'm in a total conundrum to try to understand what is happening, because I think we're at a critical crossroads. The Early Energy Upgrade California rebates, especially in rural areas of Napa and Sonoma County, when a client wanted to go all electric, no, you can't code a fuel switch because you won't get the incentive. Now with the fires and everything else that's happening, they're encouraging up to $17,500 in rebates if you go all electric, PV solar, and battery operated. Yet, the electrification and the push that direction is where PG&E is most vulnerable when these high winds happen in the fall of the year and the PSPS events happen, and we had 6 of them this last fall. And so my conundrum is, in fact, coming down here this morning on the commute is a headline on PG&E's attorney cannot promise to hire the necessary tree trimmers to provide the maintenance for their line. And in my last bill of PG&E, I get these 3 little slips that say, we're applying to the CPUC for some costs or higher rates so we can offset this tree trimming. And it'll impact our rates 1.4% higher than existing. When are they going to get their act together, number one? When are they going to provide clean, good, consistent transmission so we don't have to go through PSPS? And I'm an energy consultant. I'm trying to talk my client into some of these things like you do, Keith, when you know, dealing with your home efficiency. But I'm in a total conundrum about this whole equation that we've talked about today. I really am.
And I feel I live up in Santa Rosa, and I've gone through those 2 fire seasons, and my relative's buying the generators right now for that situation. And all I can say is what we've enabled in the energy code for solar and battery storage, those systems can be quickly enabled to be in islanding mode, where you never have to go to buy fuels for that system. The solar and battery storage can power your homes in emergency shut-off. The other end of the equation is PG&E is now mandated to look at microgrid applications to shut off those main transmission lines and still provide power in the local jurisdictions. So that's going on at the same time. The last thing I'll say is the last fire event we had, they shut off the electricity, but they also had to shut off the natural gas supply system up in Healdsburg and Windsor. And it took them almost 4 or 5 days to restore the natural gas supply system because they have to go home by home to relight pilots. And in Loma Prieta, they spent $9 million just lighting pilots. And it took them over 12 days to do that. The electricity supply was restored. Most that weren't damaged that same day after that event. So we talk about resiliency components and kind of getting back to where we need to be in livable situations. There's a time lag between the natural gas system and that. And that's what we've been talking about, decarbonizing kind of our low-income areas are also the shake-prone areas in the Bay Area that are the most, almost all the fires in Loma Prieta and our last earthquakes were natural gas breaks. So those are our most vulnerable areas in earthquakes. And we talk about fire and other resiliency events like the floods in Sandy back there. Those are all the things that we need to consider between those 2 power systems.
All right, thank you very much. I'm sorry, but we are a little over time, so we do need to end. Let's have one more round of applause for all of our wonderful speakers. And before you go, please take a moment to fill out the survey that you should just have received in your email about today's event. We really want to make these quarterly forums as useful as possible for as many people as possible, so we need your feedback to do that. Please take a moment and respond if you can. Thank you for joining us today, and have a great rest of your day.